Hey, sunshines. So we're going to find the volume of a sphere where we're given the great circle's circumference instead of being given the radius. So volume of a sphere is 4/3 pi r cubed. So we need the radius. Obviously, radius and circumference are very closely related, so it's really easy to find it. You just have to do an extra step to find it. So circumference is 2 pi r, and then we're going to plug in, we know our circumference is 12. So to get r by itself, we just divide by 2 pi. And then we want to simplify this. We don't want to just plug the whole thing into the calculator because you don't want to round off intermediate steps. 12 over 2 simplifies to 6, but it's still over pi. You don't want to convert this into decimal. You want to keep this as your true exact answer until the very end. If you're giving your final answer in decimal form, that's fine to round off, but you don't want to round intermediate steps, even if you're ending up in decimal form. So my volume is 4/3 times pi times 6 over pi cubed. Now, when you have a fraction that's to an exponent, you're actually taking the numerator to that exponent and you're taking the denominator to that exponent. It's a lot like distribution. It's not exactly the same thing because it's exponents and it's division instead of being addition and multiplication. But it's the same kind of way of thinking. So I want to rewrite this so that I have everything kind of grouped together. I want to get rid of those parentheses and just deal with the exponent, deal with each of these individually with their exponents, and I want to separate the numbers from the pies. So 4/3 times 6 cubed. So that takes care of this and this. And then I want to do times pi over pi cubed. So that takes care of this and this. So now this is all numbers. You can just plug that into your calculator and simplify it, and you're going to get 288. So 288 times, now to simplify this, you want to look at it as pi cubed is really pi times pi squared. So one pi cancels out from the numerator and one cancels out from the denominator. So that equals 1 over pi squared. So that's a simplified version of pi over pi cubed. If you're really good with dealing with exponents, then you can simplify that directly. But I know, especially in geometry classes, you don't have a lot of practice with exponents for a while. And so I see a lot of students really struggle with things like that. So it's a good idea to go break it down and show your work separately if you aren't really strong at that. Personally, that's something that I did for fun, but that's why I became a math teacher. So I know that's not necessarily what to expect from most of my students. And since that's really times 1 and you need to write times 1, I can just put 288 over pi squared. So now that's my exact answer. That's going to be 2 inches cubed. So I have a final answer, and then if I plug that in and round it off, I'm going to get about 29 inches cubed. So this part was made a little complicated by dealing with that extra pi. That's just because you had a radius that had pi in it, that was over pi. So that gave you some kind of strange shenanigans.